Open this meeting. Dr. Chris Hauser will speak to us on the potential impact of boat wakes with the special emphasis on data collected from Lake Manitouwabing. Dr. Chris Hauser is the Dean of Science and professor in the Department of Earth and Environmental Sciences at the University of Waterloo. Prior to joining the University of Waterloo last summer, he was Dean of Science and Interim Vice President Research at the University of Windsor, and prior to that, the Associate Dean of Academic Affairs and Global Faculty Ambassador at Texas A&M University. Chris is a coastal geomorphologist, and his research primarily focuses on the response and recovery of beaches and dunes to extreme storms. But his research team also looks at the bluff retreat around the Great Lakes and the social and physical dimensions of beach hazards, including rip currents. His interest in waves and boat wakes started early when he would spend his summers at the family cottage on Whitestone Lake. Welcome, Chris. We're certainly very pleased to have you.
Perfect. Thank you very much. And I'm just going to share my screen right now and go straight into it. And I know you do have another meeting that starts in a little bit here. So I want to go relatively quick. And as introduced, we're going to be looking at some of the work that we have been doing over the last couple of years, looking at the relative energy and perceived impact of vessel-generated waves in fetch-limited environments. And I'll use the word fetch several times throughout this presentation. And fetch means the distance over which the wind can blow, which means it's a major determinant on the size of the waves that can generate. And in this background photograph here, the fetch extends all the way down to that far bay on the left-hand side, about 2 kilometers. And that is what really controls that wave height in this particular picture. Now, I started working on boat wakes. I was, as was noted in the introduction, I started learning about boat wakes when I was a kid and started making the decision to go into coastal. But I started really working on boat wakes on the Savannah River in Georgia as part of their post-Panamax ship, cargo ship work, and then have since recently gone more into recreational vessels. And part of that was driven by the pandemic, when there was nothing else you could do but go to the cottage, and started looking at the boat wakes and was wondering how much energy are they actually supplying. Simultaneous with that, was working in Lake Conway in Florida to look at the impact of wake boats on 2 small karst lakes near Disney. And really, if you take a summary of what the literature says, and it's largely based upon individual boats going by and perception, is that boat wakes, whether by just a simple recreational boat or a wake boat, causes damage to infrastructure, creates safety hazards to other boaters and swimmers, can lead to shoreline erosion. You can see that the shoreline in the background on Lake Conway is in fact hardened and to protect against the boat wakes. But boat wakes, if they can extend all the way down to the bottom, can lead to sediment resuspension and turbidity, which can then help to lead to algal blooms. It can turn over the water in terms of its temperature structure, but also then potentially disrupt more that ecosystem, the ecosystems within shallower parts of the lake. As well, boat wakes are considered a nuisance and a disruption, which I'll come back to through the presentation. And really, you can see some of the examples. That last video really showed you the example of what they do when they come to the shoreline. But this overhead drone shot of a boat going through the Intercoastal Waterway in Florida really shows you some of that sediment resuspension that can occur. This one is largely due to the prop wash. You can't see it as much associated with the actual wake coming through, but it's part of that same process. And when you resuspend sediment, you are then providing more nutrients into the water column, but at the same time, you are mixing the temperature structure, and you could actually lead to a more broadening warming, a change in where that thermocline might sit. Now, as noted in the introduction, we really started working on Whitestone Lake, and this is my son on Whitestone Lake just last summer. This is where the family cottage is. We've been coming up to here for years, and it was really understanding what is that impact of wakes, and are they contributing a significant amount. Now, normally I show this picture because nobody knows where Whitestone Lake is, but you guys all know where Whitestone Lake is, just up in Dunchurch. Our cottage is just off of Highway 124 in Moore Bay. And we look down, we are right against one of the primary sailing lines. And there's a lot of wake ski, wakeboard, and tow areas that happen directly in that center point that is identified with the dashed line. And in fact, that last video that I showed you of my son is exactly from that tow area that I have identified in this shot. And what we found, this is a review from last year, but I wanted to make sure that we started with this, is that on Whitestone Lake in 2020, when everybody was at their cottage, we found that wake boats all boat wakes accounted for approximately 60% of all the wave energy. So when you look at wake energy and non-wake energy, yes, during some of the later part of the spring, early summer, there were some frontal winds that came through. But when you look at the summer, which is usually very quiet on many of these fetch limited lakes in terms of the wave heights that generate on a normal day, we found again that most of this wave energy is associated with wakes. And it really peaks during some of the, like the Canada Day civic holiday, August civic holiday, and Labor Day. Now, that is just associated with the main wake. And so you can see up in this top right-hand corner an example of what a wake looks like from one of our pressure transducers that we deployed around Ontario, including several within Manitouwabing. What you have is a flat calm water at the very beginning, and then you see the wake come through, the disturbance to the water. If you just count the wake, the primary wake, waves on Whitestone Lake, they're about 60% of them are wake energy. But when you realize, and you'll start looking at this picture in the background, and you look at the shoreline and all the rocky shorelines, reflected waves represent a major component of that. And a large amount of that, there's a lot of residual wave activity that happens on these lakes. When you include just the reflected waves, not the residual, boats accounted for approximately 80% of all wave energy. Now, I'm not trying to suggest here that 80% of wave energy is bad nor good, nor does it necessarily have an impact. It is just quite surprising that the amount of energy that is being added into the system is primarily from boats. The question is, what is that impact? And again, I'll come back to that a little bit later. And that really drove the research questions that we had in 21, 22, looking at what is the relative importance of recreational boat wakes? How does that vary with lake configuration and shoreline type? And then we ran a social science survey about the perceived issues with boating and boat wakes to better understand how perceived issues with boating aligned to the fetch length, that length of distance in front of a cottage. So the main study sites that we did the wave sampling on were Lake Joseph and Lake Rosso in 2022. And then in 2023, it was Lake Manitouwabing, Whitestone, and Otter, as well as Kashigawigamog. And also, I forgot, Lake Roslyn was also in 2021. So when you can see it on this inset map, the blue dots represent the spots where the lakes where we had wave sensors deployed. The white dots represent lakes where we got results back from the social science survey. So you can see that they're all fairly well clustered. Got a few more on the social science side towards Ottawa, but most of them are again within that Muskoka-Parry Sound region. And most of the fetch length, the distance in front of a cottage, the effective or the average was less than 1 kilometer. So again, we put out a number of pressure transducers throughout all of those blue lakes. We put them out fairly quietly. We had put out a survey to people saying, hey, are you willing to have a sensor put at your dock? We couldn't put them at every person who actually requested them at Manitouwabing, simply because we didn't have enough sensors to go around. As well as we wanted to make sure that we had a variation in fetch length, orientation, potential, sailing line, distance, etc. Because it's the speed of the vessel, the length of the vessel, the displacement, how that boat is being driven, the distance from the sailing line, and the type of activity that all also come into play as extra variables on the size of a wake the amount of wake activity that you might have. And you can see this one here. This is again Whitestone. This is on that main sailing line towards the marina. You can see the wake being generated by this boat. That would be that primary wave that you can see in that small inset graph, but you can also then look at reflected waves. So the data that we collected, what we did, and here's some example data from 2022 on Joseph and Rosso. And what we have is on this top graph, it goes from 0 seconds all the way to 4,000 seconds. And we actually sampled for an entire 3-month period, but this is just a 4,000 second record of it. And you can see that there's a background wave happening, and then every once in a while you get these big spikes of wave energy. Now, what we do to analyze this data is we use what are called wavelets. And wavelets, basically, you're putting on sine waves, cosine waves to your wave data, and you're trying to figure out to what degree is it correlated. Does it fit the data that you see? Sine and cosine waves of different length and as well as different amplitude. With wavelet, what you do is you actually put it in discrete chunks and over various different scales. I won't get into the math of it, but it means that we're able to isolate packets of waves. And you can probably see a little bit better in the bottom blue colorful graph. You can see this on that time series, relatively calm water, then this big spike of 2 wakes that came through, and then a couple of more wakes. We can identify them on that bottom graph by these very characteristic dark orange structures that almost have like an inverted comma look to them. So by being able to identify those, we can isolate that energy and say that is wake. Everything else before it, after it, under it is not awake. And so we're able to pull out that data very carefully. In that top example, wakes were about 60% of the time, but only about 38% of the energy. They weren't that much greater than the background waves. Whereas in the second case, the red dot, wakes were only 24% of the time, but accounted for 58% of the energy. So you can see that kind of data that we can get out. We can not only get the length of the wake, we can get its total energy relative to that of the wave being generated by the wind. So here's an example from Lake Roslyn. We were able to isolate the wakes very, very carefully. We didn't get into all the reflected waves because that just got too complicated, particularly when you did have wind waves. We focused only on the primary wake. On Lake Roslyn, what we found is that wind waves, non-wake waves, accounted for 85% of the time, but only 6% of the total wave energy. Whereas boat wakes accounted for 15% of the time and 94% of the energy. As well, the wave period, the time between crests for wind waves on Lake Rosalind is about 1 to 2 seconds at the maximum. It's a small lake. Whereas for boat wakes, it was 3 to 5 seconds, which means that you could get bottom velocities in this shallow lake of 5 to 6 centimeters per second. It doesn't seem that large, but it is enough to actually resuspend sediment. And this is the average. When you got big wake boats that came through, much larger waves with a short period mean you've got much faster orbital velocities, and we were actually having orbital velocities of over 10 centimeters per second. Whereas the wind waves at 1 to 2 seconds had negligible orbital velocities and really didn't stir up the bottom. And again, from Lake Roslyn, it's a 500-meter wide lake, 94%. It does cause algal blooms. It does cause sediment resuspension. There has been a loss of vegetation. And I use that because I think this is the best example of true wave wake impact. I'm going to go to some other lakes where, in fact, we don't see it that same way. And it's hard to tell if, in fact, wakes have an impact. And that's part of what we have to better understand next. So again, in Lake Roslyn, we know it's creating shoreline erosion, water mixing, resuspension, algal blooms, and a direct force to the vegetation. So let's go back to the main study sites, not including Lake Roslyn, but the main ones up in the Parry Sound, Muskoka region, as well as Kishigawamog in the Halliburton region. So this top graph is really the main piece to it. That top graph On the x-axis is the fetch length. That is the distance in front of a cottage where we placed that sensor. On the y-axis is the percent wake energy. That is how much of the total wave energy do recreational boat wakes account for. The dots that are in orange are the Manitouwabing sites. I'm not going to highlight them where they are on the lake. If you had a sensor at your cottage, you know where you are. We did have two sensors that failed on us. One completely flooded on us, and the other one just for some reason failed in terms of the memory pack. We make all of our own sensors. These sensors are normally $10,000 a piece. We make them for $100 to $150 a piece. So we're able to deploy that many. It also means that we do have some that become duds. 2 became duds on Manitouwabing. So these sites were placed in 2023, and you can see that data distribution here of the same 7 main ones that are there. They fit on this broader curve of data. And what you see is that the smaller the fetch length, the shorter the distance in front of a cottage, the greater that wake energy. The largest one, the one up in the top left corner, is Lake Roslyn. That's that 94%. And then as you work your way down through the remainder, you can start to see that the farther you get away from that sailing line, the less the wake energy is. That wake energy disperses. You have a very well-defined wake packet at the very beginning, but it's just like an accordion. It just slowly spreads out because the longer waves travel faster. And as a result, as it spreads out, it loses energy. It also, they can be breaking. There's a variety of different things that are happening as that wave moves away from that main sailing line. So, but in general, what you should notice is that across all the lakes that we looked at and all the sensors that we deployed, over 60% of all wave energy was associated with wakes, up to fetches of 2.5 kilometers. Now you notice that there's quite a bit of spread or data variability around this dashed line, some that are higher and some that are lower. So if you then break down those sites based upon whether they're on an arm, a long section of lake, whether they are open in a big, wide open middle section, whether they are in a narrow where you have to really slow down as you come in towards McKellar, there is a series of narrows, or whether they're in a bay or closed area where there's only one way in and out. By taking those and breaking down the different sites, what we find is that the areas that have our arms and bays or closed areas typically have higher than expected wake energies. Part of that is because on an arm, all you do is you go down and you come back. You're constantly going in directions. In a bay or a closed area, that's a spot where you either loop, you plow in, or you take off. So you're going to concentrate and make bigger waves in those areas. The open sections are lower than expected, but still close to that dashed line, simply because you have a wide open area in which that boating activity can occur. And narrows tend to be much smaller because the vast majority of people do follow the rules and do slow down. There are people who don't, obviously, but the vast majority of people do slow down in narrows, and you typically get smaller waves. But again, more than 60% of total wave energy is associated with boat wakes in the sites that we studied. Now, it's not just that boat wakes are slightly different. They have very different distributions to them. So here is an example from Otter Lake, very nearby to Manitouwabing. And what you have is the boat wake distribution and the wind wave distribution with the open circles. And what I've done is I've just taken that, those are cumulative distributions, but I've broken them down in more traditional looking distributions. The red being the boat wake, the wind waves being the dashed line. And what we find is that boat wakes not only occur within that same range of wave energy, you typically get much larger wave energy. So it's not just that you're adding more waves, is that you're adding more big waves to the site, particularly in small fetch environments. Whereas in large fetch environments, such as this example from Kashigawigamog, which has a fetch of 2.1 kilometers, the distributions are nearly the same, which means that this is such a big area, an open area, that the boat wakes, by the time they reach the shoreline, are no bigger on average than that of the wind waves that can be generated at that site. So you have two different things here to think about with boat wakes. One is the amount of energy that you're adding, how much more frequency, but also how much of larger size wakes that are coming in. The smaller the fetch, the more that you have a large number of big waves compared to what would be generated by the wind. We're on large fetch environments. They're much more similar in terms of their distribution. Now, the other way to consider this is by looking at essentially the ratio of wake height to wind wave height. And so what we find here is that in this lower end, smaller fetches, the distributions are very different. Wakes account for the vast majority of the energy and represent a much larger source of energy. Each wave tends to be much larger than can be generated by the wind waves. When you get to longer fetches, the distributions again collapse. Wakes still account for about 60% of the total wave energy, but the size of the waves is much more similar to that of what can be generated by the wind. So as a result, on average, you find that wakes are up to 1.6 times the size of any wave that could be generated on that small fetch. Whereas if you get to large fetches, they're getting close to a 1-to-1. The size of the wake that eventually does reach the shore on average is about the same size of the wind wave that can be generated. So if you then start to compare across all of our different lakes, Roslyn, Whitestone, Muskoka, Kashigawigamog, and Manitouwabing and Otter, you actually find that Manitouwabing has some of the highest wake energies, simply because you've got a large number of these smaller little narrow sections, channels, narrow sections, arms. You do have some big open bay areas, but also you've got very constrained bays. It's the nature of your lake. It's the design, that the way your lake is formed as a dammed lake, it is flooding up those old river valleys and creating these embayed structures. So on average, boat wakes account, at least from the sites that we sampled, account for about 80% of the total wave energy. That seems really large, but if you ever sit down on your dock one night and during the middle of the summer, not during the middle of a frontal storm, that obviously makes big waves, but through the day, you get a wind wave a wave that generates because you have a land breeze, a sea breeze, sorry, or a lake breeze. But at night, your lake calms down, it flattens out, and it flattens out through most of the evening and into the morning. And that's one of the reasons why wakes become so important, is because during the summer, most of the lakes in Muskoka Parry Sound have relatively small waves, except for that occasional frontal storm. Now, obviously, in the spring and in the fall, you get much larger waves, but that's a period of time when you've got a lot of energy, a lot of mixing already in the system. We're looking at the summer because that isn't time of the year when mixing is not as common. And in fact, in most cases, doesn't actually occur. So that's why we look at the summer, because it is a unique impact at that time of the year when things should be relatively calm. You can also look at it in terms of wake time. How much time are wakes associated with it? When you get into big fetch environments, you typically get about 12% of the time is associated with boat wakes. Whereas in small fetch environments, boat wakes are down around that 8%. The reason being is that in a small fetch environment, a boat will go by, it creates big waves, but then it's gone because the waves aren't persisting longer. In that larger fetch environment, that's an area where you can have that tow area. People are moving around in a circle. But number two, by the time it gets to you, that wave has dispersed, it's broken apart, and it's much longer. So waves do have more time in longer fetches, but account for less energy. The greatest amount of deviation in this relationship are in bays and closed environments, simply because when you get into a bay or a closed environment, Manitouwabing sits in this upper area, is because you tend to get a loop around of your boat, you tend to plow in, plow out, and so you're creating a wave that is persistent in that area a little bit longer. And again, you can see it in closed bays and areas. This is that tow area again of Whitestone. And what you see is that that's a great spot to go out into the middle of the lake. It's safer, there's greater carrying capacity, using a reference to a study that had been done on Manitouwabing. And as a result, you can move around. But just look at how many wakes are out there. And as a result, you get additive time of all those wakes just constantly coming in. Now I'm going to quickly switch to the perception survey and then show you some of the Manitouwabing data from that. Perception survey, we sent that survey out with the support of many cottage associations, lake associations, as well as Safe Quiet Lakes. The distribution of those sites are again shown here in white. Manitouwabing is in that 0 to 750 meter range as of the sites that we studied, but also that is where many of your fetch lengths are for the size of lake you have and the shape of your lake. And what we found is that when we asked about what is the largest perceived change that you have seen on your lake, the impact of boat wakes, the amount of boating activity seemed to be greatest. Water quality for the smallest areas did show up, as well as shoreline change. But really what we're seeing, and level of safety, I should apologize, missed that one there. But what we're seeing is that people were perceiving, particularly in the smaller fetch environments, which include the Manitouwabing data that is circled here, is that in fact boat wakes were a major problem. Hence the reason why this study was of interest to the Lake Association. When we then looked at it with respect to what is it primarily causing, now I apologize, the y-axis is flipped here, the way we asked the question. Most impactful is down towards the 0. What we found is that the smaller the fetch, the greater that people said that is that is eroding my shoreline. And really, that was the dominant one for Manitouwabing as well. It is eroding my shoreline. Now, that is really unique because Manitouwabing is a unique lake. It's dammed. It is a flooded environment. And as a result, many of your narrow waterways and your smaller bays had mud that would come right down and sediment that would come right down to the shoreline. It wasn't bedrock. Whitestone is almost 100% bedrock. Manitouwabing is different. I remember spending a lot of time in Herdville at some local houses of family members. And I remember the sediment and the soil going all the way down to that shoreline and it being muddy and vegetated. That's because of the flooded nature of that lake. So you do see more erosion in those type of dammed lakes. And we saw it not only in Rossland, in Manitouwabing, and in Kishigawigamog. When we asked people what were the biggest issues associated with boats, their operation and lack of experience, what we found is that the vast majority, not the vast majority, the majority, 66%, noted issues with the types of boats, their operation and the lack of experience, the way that they're playing, the excess speed, too many boats going to carrying capacity, personal watercraft, being held hostage by loud, unmuffled, oversized engines. Or some wake boats doing their surfing late into the evening when the bay is calm. This is disturbance. This is nuisance. This is not erosion. This is not sediment resuspension. What we found, and there were 635 people who took the survey, what we found is that very few respondents noticed issues related to shoreline erosion, only 9%, safety 3%, and actual damage to the property of 3%. We just spent $30,000 protecting the point of our property. I had to buy new boat lifts to protect my boat, swimmers being rocked by the boats. Our lake used to be clear, but now it's murky. I had to change the water filter many times, many more times than I used to. We were looking very carefully at those responses, and what we found is that only 9% identified something associated with shoreline erosion, sediment resuspension, water quality, safety, and damage. Most of the actual changes and descriptions of shoreline erosion were from Roslyn, Kashigawigamog, and Joseph. There were many from Manitouwabing, but not as much as these three lakes. Our shoreline eroded by 6 feet in 10 years, one site on Lake Joseph, which I was surprised at because I'd always thought Joseph is much more rocky. We have areas that are now generated big cutouts in the lake bed and stirring up the sediment. Wakes are causing damage to birds and wildlife, and they're chopping up the weeds. They're frightening loons, and we've lost a loon nesting. We saw most of those descriptions from these three lakes. The reason why we didn't see that many examples of erosion is because, as you know, most of the cottage lakes in Muskoka Parry Sound are bedrock. So shoreline erosion shouldn't be happening. Where you do have something that's interesting, and this is a picture from Manitouwabing. I'm not going to pick out the exact spot, but it's in a narrow section of the lake, this B section. That used to be sediment and mud that went right down across that bedrock. The wakes have hit to such a point, and there was a history that was provided to me of that, that now you've exposed the bedrock underneath. So look around Manitouwabing, look at where the natural bedrock is, look at where you might still have some of those flooded areas into the sediment and soil, and see where, in fact, you might be seeing some of that damage. So really, we wouldn't have expected a lot of shoreline erosion, but we would have expected sediment resuspension and eutrophication, algal blooms like we saw in Lake Roslyn. We would have expected more in terms of damage to infrastructure, as well as people commenting on temperature and mixing. This is something that we need to look at a little bit further. So I'm not saying that there's not. What I'm saying is that not a lot of people focused on that. 51 people from Lake Manitouwabing took the survey. That is actually the highest percentage of any lake who took this survey. These are just some of the representative results. Wake surf boats that damage docks and boats, unenforced boating regulations and laws, boats going too fast, too close to the shore, too noisy, too little training. Yes, slow down and plane the boat. If the bow of the boat is out of the water, the wake's going to be larger. They roar through the narrow channels. Erosion and loss of habitat, degraded water quality. Short-term rentals and younger rentals on the lake, ignoring regulations and not cognizant of the dangers of their activity. Boats going too fast, and I redacted some information here. We have boats on that have high horsepower, and they're throwing up ridiculous rooster tails and small PWCs coming too far in too fast towards the shoreline. Excessively fast boat speeds. Given the rocky shore, I don't see a large environmental impact. And I put this one in purposely because that did come across a lot in the Manitouwabing results. Yes, they're in there, and yeah, having the boats come in to the smaller channels close to shore is an impact on safety, not only in terms of the direct proximity of the boat, but also you're creating waves that can affect people who are swimming in at the shoreline. And then other examples where canoes make a wake, boats make a wake, PWCs make a wake, the winds of November make a wake. The water movement is inevitable. Stop trying to change the ripples in the water. And all boats make a wake. Now, I put that second to last one in there because, yes, in fact, those November waves during those big frontal storms as winter is coming are big. But that's a time of the year where that is natural and there's not many boats out on the water. We were, again, focused on the summer when the waters typically get relatively calm during the middle of the evening and into the night, and when boat wakes are actually going to be having that bigger impact, that time when you do see overturning sediment resuspension leading to algal blooms. So I'm not done yet. I'm going to show you a couple more slides here, but the preliminary results to this point, and it's a study that is now in press, will be published soon, is that boat wakes in the areas that we have studied represent a significant source of wave energy in fetch-limited environments. The percent wake energy and time is directly related to the fetch length and varies with the shoreline type. Is it bay? Is it narrow? Etc. But what we found through the perception survey is that there are very few clear examples of shoreline erosion, damage to infrastructure, or safety. Operation, noise, courtesy, and conflict of space were of the greatest concern. So the reason I'm putting that out there is because we need to define what is impact and tolerance. We need to look at what is that true impact of a boat wake. Yes, they're plentiful, but is it really causing that much damage? Is it really resuspending sediment? Is it helping to lead to algal blooms? So what I'm actually looking for is that, and I'll put it into the chat, is to send me a direct email with photographic, video, whatever it might be, evidence of where you've seen shoreline erosion. We need to get a better understanding as to where and what that type of impact is in these bedrock type environments on the Canadian Shield. As well as next year, next summer, 2025, we are planning to do another study. Good chance going to be on Whitestone because I can just take my own power from the cottage and run this study, but we're not sure exactly yet, where we're going to look at the impact of wakes on water quality, overturning, temperature inversions, etc. But that'll be 2025. My group is still transferring from Windsor to Waterloo, and we didn't have the capacity to run another experiment this summer. So really, what I want to identify is that a lot of lake associations, a lot of government agencies around North America are looking at, well, potentially, what could we do to limit the impact once we know what that impact is? So our study results say that wake height and energy are larger and represent a greater percent of the total wave energy. You get these two different distributions. Again, the dashed line is wind waves, the red is wakes. So one strategy is you limit the percent of total wave energy created by wakes. This is simply by limiting the boating activity on a lake to lower the frequency of waves. We're not changing the way in which boats are operating. You're not changing how fast they are, what kind of boat. Basically, you're saying, is there a carrying capacity for our lake, for this section of lake, and what will be the impact? Well, you drop that wave down, yes, wakes will become a smaller percentage of the total wave energy, but really, is it just an addition of wakes, or is it because of the biggest wakes that are the problem? So strategy number 2 is to limit the maximum wake height or energy that is reached at the shoreline. So it is very much fetch dependent. And by doing so, what you're saying is that, in fact, we are not going to allow wakes of a certain size to reach this shoreline, that which means you're going to have to change behavior. You're going to have to change, but it don't necessarily change your frequency. So there's two strategies, and it's not one or the other. It can be a combination. But the thing that's important is there an impact of boat wakes because they create a greater frequency of waves, and or is there an impact with boat wakes because they simply represent the biggest waves, things such as wake boats? Nobody really has that answer yet. There are certain studies, particularly in Minnesota, that have been done on a boat-by-boat analysis. But the problem with those is they don't look at the cumulative impact of all the wakes in the zone, and they don't look at it with respect to fetch. And so what we have to start to think about is we really don't have a definition of impact. Are boat wakes causing shoreline erosion, noticeable shoreline erosion, and we want to stop that? Is it causing sediment resuspension, temperature inversions? Is it causing damage to habitat? We have to define what is the impact, have evidence of why it's happening and how it's happening, and from that, be able to think about what are those strategies by which the impact can, in fact, be controlled if needed. So let me take strategy number 2. And this is something that is based upon some work that is being done currently in Minnesota, where they're saying, well, let's reduce not only the size of the wave in terms of that it's being generated, but the frequency of wave. So what fetch length? Where do we want to get to? We don't want to have waves any bigger than the size of the wind waves that will be generated, but also we want to have far fewer of them. So I did a very simple back of the envelope calculation. I said, what distance across all of our lakes would be required to reduce the average wake height to the average wind wave height through our study? So this is basically drawing in that wake curve so that it cannot have any bigger of a wave. And then, knowing that it depends upon the fetch length, doing some very simple calculations as to how quickly that wake gets smaller as it moves away from the sailing line. And this is stuff that was taken on Lake Conway, the one from Florida, by the Water Sports Industry Association. And what we have found is that if you want to reduce the wake height to the average size of the wind waves generated on the lakes in the Muskoka Parry Sound region, you would have to have a wake surf in deep water would have to be 404 meters away from the shoreline. A wakeboard shallow would have to be 247 meters away, and just a cruising recreational boat in shallower water would be about 202 meters. We're talking substantial distances. And when you think it's not just away from one shoreline, it has to be away from both shorelines, it's a double amount. So 404 is actually 808. So what we have actually found is in order to get boat wakes, based upon the data that we collected, down to no bigger than the wind waves that can be generated, you would have to have 800 to 400 meter lengths of shore of widths of lake in which you could have this. The problem is that is assuming that just reducing it to the size of the wind wave simply reduces the impact. Or do we need to also think about the frequency of wave energy? So it tells you that in order to put in restrictions, it's actually going to be fairly restrictive. I apologize for the double wording there, but it will be very restrictive because it is quite wide. But we don't have a good indication of impact. Following one of these presentations, this is one from Go Home Lake. And this is an example that a cottager sent me, showing me the erosion in a narrow section where now their tree is being undercut. This is not an area that is exposed to major wind waves. The main waves that actually get into this section are boat wakes. This is the kind of evidence that we're looking for to better understand where, when, and how are boat wakes causing an impact, because we don't want to get too restrictive, but we also have to recognize where those restrictions may need to be put into place. So with that, I'm going to hand it back to you, Jennifer, to moderate this. I apologize, I have not been looking at the chat throughout.
That's fine. So if anyone has a question, can you unmute yourself and ask it? Just verbally, that would be great. I have a couple of questions myself. I'm assuming that the sediment being increased, being stirred up by the boats, causing the algal blooms, that's from the phosphorus coming up with the sediment?
That is correct. So you're resuspending the nutrients within that material on the bottom. And that's one of the things that we don't know. And just before we did the presentation, you were mentioning about all the runoff that had happened with all these heavy rains. Well, some of that is going to be used up in the water column, others is going to settle out and maybe resuspended at a later point. That is actually something that is not well understood in associated with boat wakes.
Okay. Another question, do you know of any lakes that have actually banned wake boats on the lake? And,
no, I do not.
No, okay.
Not in Ontario that I know of.
Okay. So what do you think the next step is for residents on Manitouwabing to reduce the effect of boat wakes on erosion?
I think the first one is to define the impact that you are trying to mitigate. Because there's a lot of different conflicting perceptions as to what is that impact. Figure out what is that impact, quantify it, and then be able to say, okay, if we want to, if you are finding that your shorelines were eroding by a certain amount, or sediment was being resuspended to a certain elevation in the water column, that is a quantified impact. We've got to be able to say we don't want that. then that helps to define what would be the right strategy on a lake by lake basis to then mitigate that. And so that's why this whole idea of sending me images, evidence, helps us to better understand what that is. And as we start to look towards summer 2025, when we're going to be doing some of these sediment resuspension mixing studies, we can then use that as some of the background to better position our research.
Okay. Anybody else have a question for Chris Hauser? Just please unmute yourself. I see there's one in the chat here.
Yes, and that is exactly it. So in fact, people go, there's a difference in the way you go slow. One is you actually go right down onto plane and just are just simply on the surface. And the other, a lot of people come in and they go slow in a plow mode. And unfortunately, our regulations in terms of speed are based upon speed, not about the size of the wake that is being generated. There are such things as no wake zone, but people typically think of them as speed, not the way in which they're driving the boat.
I'm just trying to look for more questions and not seeing them.
I'm more than accessible by my email if anybody has follow-up questions as well.
Okay.
I have a question. This is Steve McDonnell. Chris, thanks for the talk. You mentioned you need and want evidence of erosion. Will you be sending out an email to lake associations such as ours, MLCA, asking for that, or?
I'm a little bit. First, what I'm doing right now is I'm on the tour, meeting with all the lake associations where we did our studies, and putting it directly into the presentation. But eventually, as we start to think of the 2025 sampling year, that will become something that we then distribute back out. So yes, it will come out, but not for a little while yet. That's why just use my email for right now. We're trying to figure out how you would put that out in a way that doesn't to bias the results, because there are some areas where there is no impact. We want to make sure that we're phrasing it in the right way, that we want a real sense as to where and when that impact might be occurring.
Okay, thank
I
you. I'll
see.
discuss it with Jennifer later.
Okay. I see Margaret has her hand up. Go ahead, Margaret. Yeah, Margaret, can you
Hello.
unmute
Yes,
yourself?
yeah, it took me a minute. Thank you so much, Chris. Wow, really incredible research data, objective analysis. You really appreciate it, because I'm all one of those, get those boats off the lake. But I'm on Whitestone on the south end, and in an offshoot of a closed bay. So boats do that loop for sure.
I might have done that myself, so I will take blame as well.
Oh, well, they have to turn around someplace.
Exactly.
Really, you go this way, you go that way, you have to turn around. So I totally understand that. I'm not against fun. But my concern is about shoreline habitat. I'm actually in a pretty good place where I'm letting things just naturally grow in the way they are. So I think that's helpful. My concern is more like around loon survival, and we know that wake, the nests can get washed out, and they tend to be more on the marshy side, which isn't cottage territory.
No.
So we don't really, it's kind of, we're talking about I observe this on my property, but how do we observe those areas that nobody's really watching, but have a huge impact on wildlife?
Well, I think this is where citizen science comes in, is that you've got a lake association, both in terms of Manitouwabing, but also in Whitestone, is to have people start looking at it and doing regular checks on those areas, and canoeing by or kayaking by, and looking at it and saying, okay, did we see this nest get washed out or not? This is one of the problems, is that there's so many different spots where this could be happening. We don't have eyes everywhere. And I think it takes the Lake Association to really start doing that monitoring so that you can say, yeah, it's a real problem over here in this particular bay, but over here it's not that bad. And this may be the reason why, in terms of the behavior, the way in boats go by, the way the shoreline is. And so you're hitting on exactly the problem. We just can't see everything. And that's why we would like to get more evidence, because right now it's anecdotal on property.
Great. Thank you. Well, fabulous work. I'm just stunned that, this is part of your professional research activity. So thank you so much.
I will also note that I did send the perception survey, to the Whitestone Lake Association, and they ghosted me.
I'm not surprised.
Yep.
So I'm on that association, and we'll see what we can do about things like that. Thank you.
Are there any more questions for Chris? If you can just raise your hand, or I don't see any in the chat here.
Again, anybody can contact me by email. Happy to answer any questions, etc. So, and just thank you for the opportunity to put the sensors out and to do this presentation.
Well, and thank you very much for coming this evening. We really appreciate this. And we'll follow definitely along with your research and the next step of it. So
Perfect. All right.
thanks again.
Thank you, everyone. Yes,
Take
bye.
care. Thank you. Bye now. Okay, everyone. Thank you so much for coming to this talk by Chris Hauser. I